Hey, my name is Inue.
Good afternoon, my name is Javier Lozano.
Hello, my name is Andres Vidre.
And my name is Jesus Romero, and today we're going to talk about cosine graphs and a problem with the cosines.
Here, K represents the period, where the period goes like P is equal to 2 pi over K. And this defines how many units it will go from here. B represents the phase shifting, if it goes to the right or to the left, depending on how many units does it has. And C represents the up and down shifting. It's the same case in here, that K represents the P, and X just multiplies this function.
Well, the trigonometric functions are also considered as functions of a variable to get the length of an angle. This length could be given in degrees or in radians.
Now we are going to explain the problem that we were assigned in class. The problem is about cosines. The problem says, in a predator-prey model, the predator population is modeled by the function y is equal to 900 cosine multiplied by 2t plus 8,000, where t is measured in years. So from this function, we need to first locate the basic data to make later our graph. If we see the function, we can say that the amplitude is 900. The period is given by the function 2p over k. In this function, k is given when we factorize this 2t, we put the 2 outside of the box, and we divide 2p into 2. So the period is p. And it has an upshifting of 8,000. So C is equal to 8,000. With this data, we can answer the first question, which says that what is the maximum population? This refers to the amplitude. If the amplitude is 900 and we start in 8,000, so the maximum population will be 8,900.
Okay, it's now my turn. Thank you, partner. So now given this information that my partner, we have A equals 900, which A equals the amplitude, which is, in a nutshell, the distance between this point in here and this point. Well, thank you, partner. It's now my turn. Okay. Now, given the information that we got from our partner, we know that A is 900 and A is the amplitude. And so, just to remind ourselves, amplitude is the distance between this point, which is the new x-axis, which is 8,000. I'll explain DC later. It's the distance between this point and this point and this point, but not the distance between these and these. It's the distance between the half of it, okay? And now to explain, right now, we just put a point in here. Now, just to explain the C is the upshifting. This means the graph goes either up or down. So basically, we got C as 800. So basically, we go up 8,000 units. So basically, this is our new x-axis for the graph. Sorry for my bad lines. Okay, as my partner said, the maximum population is 8,900, and given this graph, we know that at 0, with the x-axis here, the original one, equals time. That's why it's got a t here. So basically, in around 0 years, because t is measured in years, we will have 8,900 predators. Now, basically, given the amplitude, we know that in between p divided by 4 years, which I'll get to later, is we will have 8,000 predators here. So basically, this is a line here, just not to confuse ourselves. Okay. And then after 3.5 years, which will be around 1 point something years, we will have the least amount of predators according to this graph. According to our function, we will have 7,100 predators. Let's just draw another line here. And just as and then the graph goes back, all the way back. It goes, okay, in around some time later, in way after 1 point something years, we will have again the same amount of predators as we had in this time. So basically, let's draw another line here. And we will go back to where we started after the period of time has been completed. Now, what happens with the time? Because we have time as pi, and we can't just say, well, it would take pi years to go back to 8,900 predators. Well, we can't actually say that, but we can say that pi equals to around 3.1416. So basically, the time it will take for the population to be again at its maximum it will take around 3.1416 years to go back. So basically, that's question C, which we actually didn't put. Teammate, what are the applications to daily life of cosines and trigonometric ratios?
There are more applications of cosines and trigonometric ratios than we can imagine. For example, with cosine, we can calculate the height of a building. We can also calculate the amplitude of a wave of sound. This is really useful for the people that study music. And also it is used for navigation, specifically for boats, to calculate the latitude and longitude.
Well, and also it's very useful to solve problems like the problem that we have already solved of population growth. It can show you how much will be our max population and how much will be our less population and in how many time it will get again in her average population. And also like that, we can have problems from music waves or even from navigation or, well, maybe another problem from world population.